I came to work here, this was a large water storage tank. I think it stood about this high, as I remember, and you can see some of the plumbing that went to it, because back in those days when the building was built, there was no connection to a city water supply, so they had their own well and a pump to pump it up here and store it here, and the gravity flowed down into the building. And I remember when we redid the roof, we said it's time to get rid of this, so I had a outfit come out here and lift it off and take it away. You may recall I mentioned when I looked at that log from 1941 that spotlights were put up here. This is, I believe, the only remaining spotlight that was put up here in 1941 for that purpose. They were spaced around here looking out, and somewhere there was one that was somewhere over that way that looked out at the towers. But this is a remnant of right after Pearl Harbor.
So this antenna right here is a 10-foot dish looking back at Hollywood Hills. We have a radio link that comes down from there. It goes basically from our building in Burbank up to Hollywood Hills and then shoots down here because we don't have a direct shot from there. There's another one back behind it. This antenna up here is an 8-footer. It's pointed at Pleasants Peak. I pointed out earlier some gear in the rack downstairs that we use to get signals back from Pleasants Peak, and we actually also shoot a signal out to Pleasants Peak using duplexers on both ends. And we have an RP receiver and our two-way receiver up there, so that's how we get that information back here to KFI directly. Well, that's just protection for one of the guy anchors so no one can drive into it. You see that at one point it looks like it was continuous all the way around. Looks like they had to put a big notch in it there for the one guy wire. I was not here when the tower went up, so I couldn't tell you that.
That was not there originally.
If you see each of the egg insulators, you see a device that is hanging around, and that's actually a static drain choke. So it keeps voltage from building up on either side of the insulator, because we had a problem before with arcing across the insulator. So now that those static drains are there, problem eliminated.
And what about these things?
Those are oh, that's more of the same. Those are more of the static drains. Just each of the guy lines has got multiple static drain chokes on them. We also might mention that this property around the building, as you see these various trucks and these warehouses and so forth, this is all our property. So Marv actually would be the one to talk about that in terms of how the ground system is underneath this whole parking lot and so forth.
It is kind of interesting, Doug, that when we did this, we had to maintain a ground system. A wire comes out from that tower every 3 degrees, and when it approaches the building, it doesn't go under the building, it actually goes up, over, and down the other side. So these buildings are under the electrical ground system here. And we made measurements at the time when because this was done when I was still working here, and we made measurements inside the building and found that the radio frequency levels were really quite low in there with having used that technique. Let's see, that was on December 19th, forget what year, 2004, I believe, when an airplane hit the top of the original 750-foot tower here, and it collapsed. And that tower was only guyed at 2 levels, or was it 3 levels? I think it was only 2 levels. And there was a part of it that stuck 150 feet up above the top guy. And that's why those guys came down at a steeper angle and didn't have to have that cut in the circle there to do that, because now this has got guys at 6 levels, a whole different engineering scheme on this. That having that unsupported 150-foot section up there turned out to be rather unfortunate, because the airplane hit at 10 feet from the top, sheared that off because it was just direct hit. The engine just hit that tower straight on, sheared off the top 10 feet, which caused a stress to go sideways but that was resisted by the guy cables. So the next level down kicked out to the side. That then torqued against the next set of guy levels down. That kicked out the other side, so the tower just literally folded up. We're looking at the 200-foot auxiliary tower here that was originally built back in the, I believe it was the late 60s, after KNX had their main tower cut down, and they didn't have a backup tower. So KFI thought it would be a good idea to put in a auxiliary tower. And it was originally designed to maybe handle 10 kilowatts, but when I tried doing that, it barely made it at 10 kilowatts. It probably would have had to run at 5 kilowatts. So I decided to use a consulting engineer by the name of Fred Volken to redesign the matching network at the bottom of the tower, and he got it up to where we could run 25 kilowatts very comfortably in it. And that turned out to be very fortuitous, because When the main tower over here was hit by the airplane, KFI had to run on that auxiliary tower for 4 years. It took that long to get permits and everything cleared to put the main tower back up. So that was good that they were able to run 25 kilowatts for that 4 years. Otherwise, power would have probably been down at 5, maybe 8 kilowatts at the most. Looking at the tower, the main tower, you'll notice there's a circular cement block fence surrounding that. And that, I believe, if I remember correctly, has a 75-foot radius. That is not just an arbitrary number. That's a distance that was chosen because when you get out 75 feet away from the tower, then it's safe for the public to be in that area. So we exclude the public from that 75 feet so that they won't be harmed by the radio signal radiating from the tower.
KFI. Southern California.
KFI. 640, more stimulating talk radio.
KFI.
AM 640.